नमस्कार। आप सभी लोग अपने अपने घरों पर सकुशल होंगे। इसी कामना के साथ हम अपने टॉपिक की बात करते हैं। जैसा कि स्टूडेंट्स, इन प्रीवियस लेक्चर वी हैव टॉक अबाउट द कॉम्प्लेक्स परमानेंट टिश्यू, इन विच वी हैव टॉक अबाउट द xylem and its components, right? Especially we have talked about xylem, tracheids, vessels, and xylem fibers, as well as the xylem parenchyma, right? And we also talk about the some specific type of their smaller cells and how they can be growth in their conditions, in which we have talked about the primary xylem, secondary xylem, and the protoxylem, metaxylem, as well as the endarch and the exarch conditions. So I think everybody understand about this one. Let's move the another topic, that is the phloem. Means generally the second type of the complex permanent tissue, that is called the phloem. Especially we can say phloem is a bark tissue, right? Generally we can say phloem, it is especially for the conduction of the food, right, in the plants. We can say the term phloem was coined by Nagli in 1958 in the angiosperms. We can say it is also called as blast. In the gymnosperm, albinous cells and sheep cells are present over there. If we talk about the details of this phloem one, as you can just see the structures over there, means how it can be just developed from 1 2 3 4 to up to 7. This way it can be started from here and go from this side to develop. These are the mature one, right? Later on, if we talk about the components of this phloem, especially phloem have the developed with the help of four kinds of cells, or four kinds of components, in which the sheep tubes, companion cells, phloem parenchyma, and phloem fibers, right? So we have to start with the sheep tubes. Generally the sheep tubes, they are the elements which have the a long tube like structure arranged longitudinally and associated with the companion cells, and we can say that their ends wall are perforated in the sheep like manner, right? Sheep like manner, I think everybody has seen the sheep in your homes, राइट? आप लोगों ने अपने घर में आटा चालने की चलनी देखी होगी, छलनी देखी होगी, उसी जैसे स्ट्रक्चर इसका परफोरेटेड रहता है, जिससे आसानी से कुछ चीज़ें इजली पास आउट हो सकती हैं. इन द सेम वे वी कैन से द these end walls of the perforated in the sieve-like manners to form a sieve plates. Right? Evenly we can say the major sieve elements possess a peripheral cytoplasm and a large vacuole. Right? But there is a lack of the nucleus. If we can talk about the different cell organelles like the Golgi body and most cytosols. Right? So generally they are these sieve tubes, or especially in the peripheral cytoplasm, a large vacuoles are present, but there is no nucleus, no Golgi body, as well as many of the cytosol is also absent over there. So we have to know about the functions of these sieve tubes, especially how they can be functionalized. As their structure you can just see in their structures over there. Means these sieve tubes or sieve can have two types of elements, generally sieve cells as well as the sieve tube membranes, right? So we can say especially about the sieve cells, right? It is a special kind of cells which can be possess a sieve areas in its several walls, and we can say that there is no special plate in it, and sieve cells are usually found into the pteridophytes and the gymnosperm. Means generally in the plants like the gymnosperm and the pteridophytes, these sieve cells are found over there. On the other hand, if we talk about the second one, right, that is the sieve membrane, sieve tube membrane, especially we can say the sieve areas are localized on its end walls, right, and sieve tube membrane are placed one above the other forming tube called a sieve tube. Means एक दूसरे के साथ अटैचमेंट करके बनाती हैं, तो जिस वजह से क्या होती है, sieve tube कहलाती है. As well as we can say the end wall of the perforated means sieve pores, the holes, right, means the at the end of those walls they can have the small holes, sieve pores like the sieve and they can be especially found in the angiosperm plants. Evenly we can talk about that these sheep tube have unique structure, that they are even without nucleus, but it is a living and right. इसकी एक स्पेशलिटी यही है कि इट इज़ without nucleus, but it is a living, and the nucleus of the companion cells control the cellular functions. Means the companion cells nucleus can be control its functions. If we talk about the function of these sieve elements, we can say the main function of this sieve element to transfer or translocations of the organic solutes. Means generally translocation means the transfer of the food materials from one side to the another side in the plants, that is called translocation. And especially we can say these sieves can also help for the translocations of the organic solutes from one to another one. And we can say the cellulose especially which can be developed inside the plants, right, that cellulose is present in the perforation in the sieve plates. As well as we can say it is soluble and disappears when the solute is dilute, so that the solute can be passed from one cell to another. During right, the cellulose reappears and sometimes closes the pores when solute is less dilute, thus stopping the movement. Generally, how this cellulose can be passes out, especially the cellulose is in the formation of solute, right, and when it dilute means when it can completely, when the solvent percentage is higher in compared to the solute one, so we can say in that particular time the cellulose can be easily passes from the pores of these sieve, right, but and after passing it again convert into its cellulosic form. But generally if the solution is very concentrated in that particular conditions, this cellulose can be helpful for the stopping of such passing of the cellulose from there. So after that there is another conditions of the elements of the phloem, that is companion cells, right, especially the companion cells we can say they are the specialized parenchymatous cells which can be closely associated, means they are closely attached to each other with the sieve tube elements, they are attached with the sieve tube. Usually we can say the single companion cell is found associated with the sieve tube membrane one, and we can say the cytoplasm of the sieve tube elements and companion cells are connected by thin cytoplasmic strand called the plasmodesmata. Means generally the cytoplasm of the sieve tube and the companion cells was generally attached with each other with the help of the plasmodesmata, and the passes through the pit membrane in the balls. The plasmodesmata से आपस में के साथ साथ between there is a pit elements are found through which this substance can be attached to each other. As well as we can say the companion cells are absent in the phloem of the pteridophytes and gymnosperms. Generally you must know the companion cells are absent in the phloem of the pteridophytes and the gymnosperm. As I have already told you that the sieve tube are or the sieve cells are present in the pteridophytes and gymnosperm, right. So we can say especially in the these pteridophytes plants and the gymnosperm plants, this companion cells are absent, so we can say that they have a albuminous cells in the abdomen which can be contains to food materials, right. Especially if we talk about the companion cells, especially companion cells, as its name says, the company, it can always provide the company, and we can say the companion cell is associated with phloem parenchyma, plays an important role in the maintenance of the pressure gradient in the sieve tubes during the food transportation. Means this can capable to increase the total pressure gradient in the sieve tube, so that food can be easily transferred from over there. Means it can be always helpful for the maintenance of the pressure of that food in the sieve tube, through to which it can be capable or it can be helpful for the regulations of the passing of the material from the sieve tubes. So it can be always helpful, as you can see in the diagram. Then we have to come on the phloem parenchyma, right? Then we have to talk about the phloem parenchyma, right? Especially as the phloem parenchyma is made up of the elongated and tapering cylindrical cells, right, which have the dense cytoplasm and nucleus also. And we can say that the cell wall is composed with the help of cellulose and has pits through the plasmodesmatal connections. Means wherever plasmodesmata are connected, there is a such substance as cellulose is found over there. And this plasmodesmatal connections, it can be always helpful for the exits between the cells, right? And we can say the phloem parenchyma is absent in the most of the monocotyledon plants. Means generally the parenchyma is absent into the monocotyledon plants. Evenly we can say that the function of this phloem parenchyma, especially as the parenchyma tissue is over there, so generally the function of the parenchyma tissue is to store the substances, to store the food materials. In the same way, in the phloem parenchyma tissue, it can always helpful for the storage of the food material and other substances like resin, latex and mucilage. There are different substances in the plant which can be stored in different ways. So we can say they can be stored in the plants one, right? And the last topic of this complex permanent tissue, we can say that is the phloem fibers or the blast fibers, right? Especially these are made up of the skeletal chymotous tissue cells. As you know that as we have talked the simple permanent tissue in which we have talked about the collenchyma, parenchyma, sclerenchyma. In the same way, here the skeletal chymotous cells, means the phloem fibers, they are made up with the help of skeletal chymotous cells, and we can say generally they are absent in the primary phloem, but they are found in the secondary phloem. While the development of the phloem is started in that particular time, this skeletal chymotous fibers, or we can say cells, are absent, but whenever it can be completely developed, the secondary phloem, in that these cells are found over there. And we can say the cell wall of the phloem fibers is very thick, right? And these are much elongated, unbranched and pointed apexes. And we can say at the maturity these fibers loses their protoplasm and become dead one. Means generally phloem fibers are dead in this condition in the phloem tissue. And the phloem fibers are of the jute, as we have seen in jute, flax and hemp. They are important economic use because generally they can be utilized for the making the ropes, as the we can say fibers of these plants which can use for the such developing different substances. As well as we can say the first formation of primary phloem consists of narrow shaped tube and referred as the protophlloem, and the later formation of phloem bigger shaped tubes, they are referred as metaphloem. Means with the help of the development of the phloem, whenever the primary stages of the development of this phloem, in that particular conditions, we can say they are developed with the help of the shaped tube in primary phloem. In that particular conditions, those phloems are known as protophlloem. And later on, whenever the plant can be going to be mature, in that maturity, they can be have the bigger shaped tubes, and they are known as the metaphloem in that particular condition. Then we have to talk about the next one, in which we have to talk about the tissue systems in the plants. Especially we can say the tissue systems means generally the tissues are vary and they can be depending upon their locations in the plant body, right, and their structure, functions and their locations. So on the basis of they can be again classified in different categories, that is the epidermal tissue system, vascular tissue system and the ground fundamental tissue system. So let's begin with the vascular tissue system. Especially we have to talk about this vascular tissue system. Means generally there is a specific type of structures which can be found in these plants, and as we know it is as the vascular bundles, right? Means we can say it can especially related to the conducting tissues which can be generally composed of xylem and phloem, as we have already discussed, right? In the monocot and the xylem, phloem and cambium in the dicot. Means generally these vascular bundles can be differentiated into the monocot and dicot also. We can say that in the xylem and phloem are generally found in the monocots, and in the xylem, phloem and cambium they are in the dicots. And if we can say that these tissues originated from the procambium and apical meristems, and we know that the arrangement of xylem and phloem is the characteristics of the particular plant organs. So these can be always helpful for understanding to the different parts one, right? Evenly if we can talk about these, that on the basis of the arrangement of xylem and phloem in the vascular bundles, right? There are three types of bundles are found over there. Means there are three types of vascular bundles are found over there. So we can say they may be, right, known as radial, conjoint and the concentric, right? And sometimes we can say they may be collateral, as you can see in, if we talk about some other places, means how they can be joined together, how they can be developed in different plants. So in that particular conditions we can say that their distributions are found over there, right? If suppose we want to explain the radial type of vascular bundles, in which we have to know, suppose the such structures you can see in like this one. Means the structure of these are the, we can say, xylem, and these are the phloem. So if the arrangement is like this, we can say the xylem and phloem are alternative with each other, spread by the parenchymatous cells, and this type of vascular bundles are known as radial. Means the arrangement means xylem, phloem, xylem, phloem, xylem, phloem. So such arrangement are found over there in the parenchymatous cells. In that particular condition we can say it is known as the radial type of the vascular bundle. On the other hand, we can say they are conjoint type of vascular bundle. Especially in the conjoint type of vascular bundle, there is something is different. We can say when the xylem and phloem are present together in the same bundle on the same radius, that is known as conjoint bundles, right? They are found over there. Means generally, suppose we can say they are found in same bundles like this. Suppose like you can just see in the diagram, right? So this is the phloem and this is the xylem, and the middle line that is known as cambium, you can say. So in that particular conditions, when the both xylem and phloem are present together in the same bundle on the same radii, they are known as conjoint bundles. And generally these conjoint bundles are especially two types which you have written over there. That is called collateral and the, right, they are sometimes known as underway and bicollateral. Generally, if we talk about the collateral, right, this collateral can be again classified into two categories. That is, we can say the open and the close. Right. If we talk about the collateral type of conditions, in which, as you can just see, the occurrence of the same radius vascular bundles is that called collateral. Means we can say, especially the xylem and phloem lie together on the same radii. In that particular conditions, the xylem is inside or lies inward and phloem is outward, as I have already shown in the diagram, in previous diagram. Suppose like this, right? This is pith region, this is the xylem and this is the phloem. So in that particular conditions, they are known as the collateral one. Right, and if we can say about these collateral, the open and the closed, generally in the dicot stems, the cambium found to be present between the xylem and phloem. Such bundles are known as open, right? Especially in the dicot plants, if we can say, right, and you can just see diagram like this. This is known as the phloem, right? Sorry. This is cambium, this is phloem, and this is xylem. Right? So we can say, especially in collateral, I have already told you, they are found in the same radii. दोनों के दोनों क्या सेम रेडिया के ऊपर डिपेंड कर रहे हैं. साथ ही क्या होता है, when the both, right, they are found between the xylem and phloem, and in the especially dicot plant, right, dicot plant में मिलेगा जिसके xylem phloem और xylem के बीच में cambium ring present रहेगा. Right, such plants or such vascular bundles are known as open type of vascular bundles. So this can be found in the sunflower like. And if we talk about the dicot plants, right, in case of dicot plants, there is some other thing, very minute difference, means especially we can say in the cambium is absent, the vascular bundles are closed, especially when you can say when the vascular bundles are over there, phloem and xylem are found over there, and the ring of cambium which we found, that is absent. In that particular conditions we can say the vascular bundles are closed, right? And if we talk about the bicollateral type of vascular bundles, in that particular condition they are the conjoined vascular bundles with two groups of patches of the phloem on one each side and centrally located xylem. Means generally bicollateral conditions में क्या होते हैं, single collateral में क्या है, they are found in the latch together in the same radii, right, and the xylem is inside and phloem is outside. But in case of the bicollateral vascular bundles, they can be conjoined vascular bundles with the two groups of the patches of phloem on each side of the central located xylem one. Means दोनों ही कंडीशन में आपको पैचेस मिल जाते हैं. साथ ही भी कह सकते हैं the various components are arranged in the sequences of outer phloem, outer cambium, xylem, inner cambium and inner phloem. Means simply in bicollateral you can say in that particular conditions, if we can draw its diagram over there like this, right, suppose this is the cambium ring, right, so in that particular condition we can say this is the phloem, this is the cambium and this is the xylem. Clear? Then after that we can say in case of the bicollateral, in that we can say the outer phloem, this is the outer phloem, right, outer cambium, this is the outer cambium, then xylem, this is the xylem, inner cambium, this is the inner cambium, right, and then inner phloem. तो इसके अंदर की साइड से क्या होगा, जो आपका phloem रहेगा, मीन्स जो लेयर बाय लेयर रहेंगे उसके बेसिस पे क्या है, दे आर नोन एज बाइकोलेटरल टाइप ऑफ दी conjoint vascular bundles. So such bundles are commonly found in the members of the Cucurbitaceae family, where we can say the such bundles are always open type, right? And there is another type of vascular bundle that is known as the concentric structures, right? We can say especially the concentric type of vascular bundles, in which we can say the vascular bundle in which one tissue is completely surrounded by the other called the concentric. एक टिश्यू जो है दूसरे से पूरी तरह सराउंडेड है तो उसे हम कंसेंट्रिक कह सकते हैं. द कंसेंट्रिक बंडल्स आर टू टाइप्स, स्पेशली एम्फीबेसल, right, amphibiasal, in which we can say the phloem lies in the center and remains completely surrounded by the xylem. If we talk about that amphibiation conditions, right, you must suppose this is the phloem, so it can be completely surrounded with the help of the xylem, right. This is xylem and this is the phloem one. In that condition we can say they are the cerebral also amphibasal type of the vascular bundles. On the other hand, when we can say xylem is lies in the center, when and sometimes when the xylem is in the center and phloem is out just concentrating outside it. In that particular they are amphicerebral, means xylem lies in the center and remains completely surrounded by the phloem. In that particular condition, these bundles are known as concentric, right? And they are known as amphicerebral type of the vascular bundles. So students, you all must read them properly. The remaining type tissues we will discuss tomorrow, right? In that is the epidermal tissue and the ground tissue, and you all must try to make your notes with the help of diagrams. Thank you.